Hello, this is Keith from Kinvert, and this time I'm going to be giving you another example using a linear equation, y equals mx plus b, to model some actual data. Now, this data is basically made up, but it's going to represent a real-life use of y equals mx plus b and algebra. And it's probably going to go over simultaneous linear equations. I know what I'm going to do, I just don't know all the steps. So what we're going to be going over is how would you kind of predict the price of a car. Okay, so let's say you're looking at a Chevy Cobalt, okay? And what you do is go online, and let's say you go to Kelley Blue Book, okay? This is where you can get some of the data. I'm going to make up these numbers, but imagine that you could replace these with real data. And let's say that a 2014, I don't even know if that's a real year of a Cobalt, but we'll just go with it, okay? Let's say that when they're at around 20,000 miles, so 20,000 miles is going to cost, let's just say $7,000. I'm making these numbers up. And then let's say on the high end, let's say 120,000 miles correlates with the price of $2,000. Again, just totally making these numbers up. And so what I want you to do first is try to visualize this graph. Which is the x-axis? Which is the y-axis? Is the x-axis the mileage? Right, so these are miles, miles, and then this is a price. Right, so we're looking at dollars, price, and I want you to think about that. What is the x-axis? What is the y-axis? So let's start to draw out our graph here, and it could potentially even go down, these directions. So is this going to be a graph that looks, I'm going to draw this so it's easy to erase. Is the graph going to look like this? Is it going to look like this? Where is this going to end? Is it going to, we're going to do linear, so don't worry about stuff like this, okay? But is it going to be positive slope, negative slope? Is that y-intercept going to be above, positive b value, negative b value? So start to think of that while I erase this, and then we're going to dive right in, okay? So again, we are looking at y equals mx plus b, so I'll switch colors here. So we're looking at a y equals mx plus b. This is the slope-intercept form. And so here comes the answer. I hope you thought of it. So for the price is dependent on the miles, right? And so we're going to have the money here. Derp. This is the miles. And this y-axis is the money. Okay? So now what we're going to do is set up the two equations. So remember, pause this if you need to. I'm about to set up the equations. Please try to figure out how you would set these equations up on your own and solve for this linear function. Okay? Please pause it. I'm going to start talking about it now. So what we're going to do is, since y is this, we're going to say 7,000 equals m, which is currently known, times x, which is 20,000, plus b. And then the other one is 2,000 equals m, which is unknown, times x, which we have set at 120,000. And just imagine that this was real numbers from, like, for example, Kelley Blue Book, plus b for the y-intercept. And I'm going to start calculating this, and hopefully you do the same. So pause this video and try to solve this, and I'll be right back after I punch the math here. Okay, and we're back. So let's start seeing what this equation is going to look like. Since this is kind of solved, let's go to here, I guess. We have y equals m, which is, in this case, negative 1/20, like this, times x plus b, and b is 8,000 according to this. So what's that going to look like? let's say that this is 20,000 miles. This is 120,000. So 120K and 20K. The price for a 20,000 mile car is going to be up here, let's say, at 7,000 is the price there, and then here the price is at 2,000. Okay? And so this line, hopefully you can recognize that this is a negative slope, which makes sense when we're looking at the M value here. This is M, this is B, this is the y-intercept, and so theoretically if you continue to extend this line, this is going to hit y, and the theoretical price for, again, this is not going to perfectly correlate with real life, we're just trying to show how you can get estimates here. This is going to go to $8,000 if you somehow found a 2014 Cobalt, which might not even exist, at 0 miles. Let's just say that that's worth $8,000. Again, you would get real life data for this. And let me give you that as an assignment, right? Try to do this on your own. And yeah, so we just applied y equals mx plus b. We found the slope. And here the slope is, what would you call this? You would call it a depreciation per mile. Per mile. So you could even calculate this and say, hey, how much is my car going to depreciate for each mile I drive? And the answer is literally 1/20. In this made-up case, is you're losing a 20th of a dollar every mile. And so we're talking, what, 5 cents? 5 cents per mile? And that seems somewhat kind of close. So 5 cents per mile is the value that you're losing in the car. And then the other thing to think about, okay, where would you want to buy on this? Let's say that you find a car that you look it up and it's at 25,000 miles, and the price is here. I don't know exactly what that be. Let's pretend that that's 4,000, let's call it 4,500. Okay, and then you've got another car that is over here at the same price, right? At the same price, but now it's at, instead of, let's pretend that's 30,000, I don't remember what I said, and then this is like 80,000. Which is the better value? Hopefully you can already guess. And so then you could get into, this would be another interesting one, is finding which one is the best value. If you've got a car that maps out here, a car that maps out here, a car that maps out way down here, where it's practically free. Let's say that they just blew a head gasket. It's an easy, well, head gasket's not an easy fix. But anyway, that's the big thing. What is the better value? Do you want a car that is above the line or below the line? Okay, so this was Keith from Kinvert. We showed an example of y equals mx plus b, a linear equation to estimate, proximate values. What's a reasonable value based only on the miles and price of a car to look at this. And by the way, the answer, you want to buy a car that is under this. And the lower the better. So this one over here, this one's pretty low. This one's pretty low. These would be two of the strong ones to look at, unless you really want a newer car. But anyway, again, Keith from Kinvert, and we'll see you guys later. Thanks. Bye.